Okay, we're going to differentiate this formula here by using logarithm properties. First thing I'm going to do is take the natural log of both sides. So basically, ln of y equals ln of x to the 3/4. I'm going to put that times the square root of x squared plus 1 all over 3x plus 2 raised to the 5th. Now, what I hope is that you recognize that there are three objects that are connected by multiplication and division, and we have a property that allows us to break up multiplication and division of exponents, so, or of logarithms. So we're using our addition and subtraction of logarithm properties. What I mean that is we have the ln of a times b is the ln of a plus the ln of b. Oops, I'll write that in cursive. ln of x squared plus 1 minus the ln of 3x plus 2 all raised to the 5th. Next thing I'm going to do is bring out those exponents. So I have a 3/4 ln of x plus a 1/2 ln of x squared plus 1 minus 5 ln of 3x plus 2. Okay, now I'm going to take the derivative of each one of these pieces using implicit differentiation and a combination of u substitution or chain rule. So first one, that's the chain rule. The derivative ln of y is 1 over y times y prime. And I'm going to continue with this. The next one is going to be 3/4 times 1 over x plus, next one, 1/2 times 1 over x squared plus 1. But now I have to take the derivative of x squared plus 1 because that's chain rule, which is 2x, minus 5, and I'm taking the derivative of that, times, oops, let me slide this over, 1 over 3x plus 2, and again, I have to take the derivative of the 3x plus 2, and that gives me a 3. So, just using the derivative of the ln with the chain rule, I'm going to simplify this a little bit. So I have 1 over y times y prime equals, let's see, I've got 3 over 4x plus 1 over 2 times x squared plus 1. Sorry, I have that 2x on top. I'm going to write that 2x just right on top, and then I'm going to reduce those 2's out. Minus, let's see, on this one, top times top, 5 times 3 is 15, and bottom is 3x plus 2. So, let's see, since I've reduced that out, this is my final reduced fractions. And now I'm going to multiply both sides by y, and y prime is my derivative. So I have y times all of that, 3 over 4x, plus x over x squared plus 1, minus 15 over 3x plus 2. And the only thing we need to finish this is to know what y is. And y is my original question, which is x to the 3/4. And let me copy and paste that so I can pull that down here. It's a lot to shrink that down and copy this because that's my y value. Excellent. Paste that here so I can replace my y with that. And I will have my final answer for my derivative. So y prime is going to equal, actually, let's change that to red. So, I'm not sure why that is. Okay. It's writing in black, but that's okay. So y prime equals y, which is x to the 3/4 times the square root of x squared plus 1 all over parentheses 3x plus 2 to the 5th times, and again we're just bringing this over, 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. Now notice, that's quite a big answer. However, really the derivative only had 3 pieces involved, or 4 pieces involved in that. 1, 2, 3, 4. Those were the 4 pieces I was taking the derivative of, and they were all very simple derivatives. So that is using logarithms to take a derivative.